So here's why we're here. UCSF raised some money a bunch of years ago and built this building for cancer research of all kinds. And I've been talking to people about this, about what they want to spend the money on. And basically the deal is that it took them a while to get the construction going on that building, and the cost of everything kind of increases with each year. And by the time they were done, they had this 5-story building, and everything was done except for the 4th floor. And they will totally let you visit if you want, and it's completely boring. It's empty, it's drywall, there's concrete floors, there's space that was supposed to be filled with laboratory benches and researchers, there's nothing there. And if you talk to Mitchell Berger, who's the director of the Brain Tumor Research Center and the Neurology Research Centers, not to mention he's the Brain Tumor Surgery Center that he's head of, and he's also the president of the American Association of Neurologic Surgeons. Like after I talked to him, I looked at my career, I was like, oh, you're the king of the brain doctors. That's who you are. If you ask him, he'll tell you that not having that space functioning has put the researchers in a very strange position.
It's the most bizarre thing, I must say, that I've ever seen in my 27 years in academic medicine, is we have the money to hire people. We have people out there who would love to come work with us, but we have no space. It's that simple. In fact, I had a great guy who we lost because he wanted to come desperately. I had no place to put him. I had the money to hire him. I had no place to put him.
The situation now in our labs is that we have almost 2 people for every lab space available.
This is Dr. Russell Pieper, who oversees the brain cancer research at these labs. He's the principal investigator and director of basic science. These people who he has now are crammed in elsewhere around the building.
In essence, we have people sort of, they don't have the space to sit or do their research, more or less. They kind of take turns. They, find some other place to sit when they are not doing an experiment. They share the lab bench with someone else while they're doing the experiment. So we're really, it's a real beehive. It's really overpacked.
Dr. Pieper is actually he's the person who scientists in the lab come to when they have space questions and issues. And typically what happens is somebody comes to him and he or she wants to hire a new person on the project. And then he has to tell them, sorry, there's no space.
So, that happens pretty frequently, actually.
Really? How frequently?
Probably every other week, I would say.
Wow.
Somebody knocks on the door and has pretty much the same story. Here's somebody who wants to work in my lab who will cost me nothing. Somebody else is paying their salary, or they have a grant to do something. They have funding to do this. Can I bring this person in?
He's resourceful, and often he is able to figure out some way to squeeze them in among the other people, or you take this time and this other person will take this time during the day. Though he says about a third of the time he can't do it, and there's nowhere to put them. And the biggest way that this affects scientific progress is that it means that there are all kinds of things that they want to do that they cannot do. Dr. Berger told me that it is like driving with your foot on the brake.
That's the problem, is that we have a whole bunch of new areas we want to get into. The labs we have now and the investigators we have now want to expand, but they can't.
For example, genomics. Genomics means that they're looking at the genes that are responsible for tumor formation, and they're trying to find the drugs that would target these genetic pathways. And this is the radical thing that's happened in cancer research in the last few years, is that since we can look at the genes of things, we can start to do this. And Dr. Berger explained to me that doing it is a massive undertaking. It's very time-consuming because basically you have to look at all the genetic mutations in each tumor, like you compare it to an unmutated genome, an uncancerous genome of a person. And then once you find the ones, okay, these are the ones that are the mutations, then you have to look at those genes and the interactions with genes, one after another after another. It's like an act of brute force. You're like crunching the numbers of this thing, and you're looking for pathways that you can target with drugs.
Because there are drugs that exist out there through pharmaceuticals and biotech companies that we can use to target those pathways.
And so are we like at 1/10 the power that you want to be? Like, in other words, is it like you have one researcher on this and you want 10? Like give me a sense of a scale with this.
I think we're kind of sitting back at about 30% of where we should be. So I'd like to ramp it up twofold. double the laboratories and then build into that from there.
That would mean 4 or 5 new faculty members, each staffing their labs with a half dozen to a dozen postdoc assistants, grad students, et cetera.
So you put that all together, that could be 60 new people.
And does the money exist for the research, but you just don't have a place for it?
Yeah, and that's really kind of the irony. Is so the money exists, we have the NIH funding, we do have some private sector funding as well. So we have the capability to do the work, we just don't have the physical plant. Yeah, it's crazy.
They're doing the work, but at a much slower pace than they want to go. I have to say that one of the amazing pleasures of getting ready for this event tonight was getting to talk to the scientists at UCSF, because it is like talking to NASA scientists in the year 1967 as they're plotting their way to the moon. There's so much to do, and they have so many promising leads, and they have the technology and the ability to explore them. What one of the doctors said to me tonight at the reception, he was saying, like, there has never been a moment like this in cancer research. It's just busting open because of all the genetic stuff that they can do now. It's a very exciting time. They say things like,
It's really astonishing to me how much we know more about brain tumors now than we did even 5 years ago.
that's Dr. Pieper. So if you happen to meet with one of the scientists tonight, I mean, they're all around you here tonight, or you get the chance in the future, I really, really encourage you to talk to them about what they're working on, because it's fascinating. It's really, really fascinating. Dr. Pieper told me about this whole area of research that tries to harness our own immune systems to kill the cancer. And he said, okay, so think about it this way. We have these immune systems. They're supposed to kill, like, disease, anything in foreign, weird stuff in our body, unusual cells. Okay, so here's a question. Why doesn't it kill off the cancer cells in our bodies? Like, right, that's their job, is to kill off stuff that's dangerous to us. Why doesn't it do it? Well, the answer is, for one thing, the cancer cells put on a disguise. To do that, they
Change the proteins they express on their surface, and the immune cells don't recognize them.
In other words, the immune cells see these proteins that are a disguise, that it's a trick. And the immune cells are like a cop walking the beat, and they're like, nope, nothing here, nothing to see, and just completely pass them by. It's very spy versus spy. And how that works, the acts of disguise, is one of the areas of research at UCSF. And then the second thing that cancer cells do, there's a scientist named Andrew Parsa at UCSF who's shown this in his work, is that they create proteins on the surface of their own cells that kill any immune cells in the neighborhood. So immune cells are kind of like scouting around your body, bump up against these cancer cells, and then they never get a chance to kind of relay a message back to base and harness the body against them, because the cancer cells can just kill them off. And Parsa, this guy Andrew Parsa, what he's working on now is a vaccine that will train our immune systems to recognize the cancer cells as the enemy, as something they're supposed to kill, despite the tricks that the cancer cells are trying to pull that they don't get seen, right, that they're trying to deceive. And this vaccine is actually pretty far along. They've gotten to the point where they're doing clinical trials. They have, in very small numbers of patients, very small populations of patients, successfully trained patients' immune systems to attack a glioblastoma tumor and kill cancer cells. Though I should say this is still very early stages of testing, and they haven't done like the big case control trials. Here's Dr. Parsa, who's doing this work.
It really looks very, very provocative. It really looks exciting in terms of increasing the overall survival in our patients. But you just never know until you do a randomized study. But we think we have something.
Now, if you had more space and more manpower, what difference would that make in this kind of research?
We need more space so we can get more people on the field to fight this disease. With that space, all those people we could bring in would really expand the applications of this immunotherapy protocol to other types of brain cancer, other types of patients, pediatric patients, patients who are under the age of 18 with a malignant brain tumor, for whom we've exhausted all our options. Having more space would allow us to move that forward.
Has there been a moment in the last few years when you've wanted to hire somebody and expand in some way and you haven't been able to?
Yeah, yesterday.